Okay, today we're going to do ionic bonds, and I hope you can actually see what I have written on the board up here. I'm going to tilt it up a little bit and bring it closer. Okay, so with ionic bonds, this is the giving and taking of electrons. You only use the outer layer. It only occurs between a metal and a nonmetal. And when the bonds form, both elements must have a full shell of electrons, which means 8 or 2 or 18. We're only going to be making bonds between the first 20 elements. So that means all of our full shells are going to contain 8 electrons. All right. Now let me show you what I mean. So right over here, I have written sodium and chlorine 2 different ways. The first way right here is the way that we did it in class Tuesday, where you've got your Bohr model, you show your 2, 8, and then your 1 valence electron here for sodium. Sodium has a total of 11 electrons, and I've got 11 total electrons right here. Chlorine has a total of 17. And because it's in group 17, it has 7 valence electrons in the outer level. Okay, so we've got 2, 8, and then 7 in the outer level. Okay, sodium is in group 1, so it just has 1 electron in the outer level. Now you can write it a different way, a simpler way. Okay, you can write just the valence electrons around your element when you do your bonds. This is called an electron dot diagram, or just dot diagram. Okay, they were actually founded by this guy named Lewis. So sometimes you'll see him referred to as the Lewis dot diagram. So this is a simple way of showing how bonds occur, but I wrote it this way so you can understand why there are full shells underneath each bond. Okay, so as you can see from here, sodium has 1 outer electron that it desperately needs to get rid of, because underneath it has 8 electrons and it has a full shell. Okay, it's stable when it has 8. It's very unstable with just this 1 right here. So chlorine is unstable because it has 7 and it needs 1 more to become stable. So it really wants to bond with any element that has 1 electron that it can give it. Okay, so that's what happens with an ionic bond. This electron from sodium is given to chlorine, and that makes chlorine have 8 in its outer shell. And then because you've gotten rid of this one, now sodium has 8 in its outer shell. Okay, so this is the whole mechanism between it. This is why we do this. So you're going to give 1 electron from sodium to chlorine. So it's going to go and it's going to bond right there where I made that X. Okay, and you only need 1 of them. You only need 1 sodium for this chlorine, because chlorine only needs 1 extra electron and sodium only has 1 electron to give. That's why we have a bond called NaCl. That's the name of this molecule right here, NaCl, which is salt. okay? Just regular table salt. Now, let me show you a different way, okay? We're gonna work a different way. And this time, I'm gonna do one that needs more than one electron. So let's do calcium and chlorine. Okay, so calcium is in group 2, which means it has 2 electrons in its outer layer. Okay, and again, chlorine still has 7. Okay, so we've got 1, 2, 3, 4, 5, 6, 7. Okay, this one's a little bit tricky. In fact, I'm going to put my X's right here for calcium. Okay. You have to get rid of both of these electrons for calcium, okay? Chlorine can only take one of them. So let's say you have a beaker full of calcium and you introduce chlorine into it and you only have those 2 molecules there, nothing else. Chlorine is going to bond in as many places as it can with calcium, okay? And calcium has 2 places that it can bond because it has to get rid of both of these electrons. So you can put 1 chlorine over here on this side, okay? And then you're going to add another chlorine to take up this other electron right here that you have to get rid of. So you're going to end up using 2 chlorines to take up both of these calcium electrons. Okay. Now let's look and see the reverse, where you might need to use 2 of these and only 1 of these. Okay, oh, and by the way, because you've got 2 Cls right here, your formula for this is going to be CaCl2. Okay, because you have 2. All right, so let's look at one where you might need 2 metals with 1 nonmetal. All right, let's see which one that would work out with. Lithium and sulfur. Okay, so we're going to do lithium, which has 1 electron in its outer layer because it's in group 1. So it has 1 electron that it has to get rid of. And then sulfur is in group 16, which means it has 6 electrons around it, okay? Now, sulfur has to fill up both of these spots. It needs 2 more electrons, okay? Lithium can only give it 1 at a time. So we can go ahead and bond it here. And then you've got another open spot right here where you can place another lithium and put it right there, okay? I'm going to erase this right here. And to write this formula, because you have 2 Li's, it's going to be Li2S. Okay. I know this is confusing because we just went over Bohr diagrams and now we're looking at a different diagram. This is just a simpler way to write your bonding with the valence electrons. Remember, valence is just your very outer layer of electrons. So please send me an email if you have any questions. Your worksheet today, you only have to do the problems for the ionic bonds. Tomorrow, we're going to go over covalent bonds, and then next week, we're going to do some test review where we cover a little bit of everything, getting you ready for the ACAP test.